Hi, this is Brandon from Talk Tech, back here again with another video. So I wanted to start this video with a question. Have you ever plugged in a device such as a USB drive, external hard drive, and wondered where the heck it is? Well, most Linux systems do not mount disks automatically. So you may be scrambling around trying to find it, looking through different locations in the file system, and you're just not finding it. Well, there's an easy way that you can do that. Now, this command that we're going to be going over, which is lsblk, will help you identify those all elusive drives. Now, the syntax for the command is going to be lsblk options and then device, as you can see here inside the man page. Now, if you want to get more information about the specific command, just insert the command man lsblk into your terminal, and it will pull up the man page. Now, this command will list information about all available or specified block devices. Block devices are things such as external hard drives, USB drives, things of that nature. What it's going to do is it's going to read from the sysfs, which is the /s sys directory, and then the udev database to gather information. Sys directory is a virtual file system mounted at each boot. In RAM, this virtual file system has information on kernel modules and many other components, devices and their drivers, as well as file systems. Many of the files are read-only. You can get more information about the sysfs and the /sys directory using the man page, man sysfs. Now, udev, this takes care of devices that are plugged in from the system. Anytime you plug in like a USB or external drive, it's going to be picked up by udev and be recognized by the system. Now, keep in mind, just because udev recognizes it does not mean that it's actually going to mount it or anything unless you actually have rules set up to where that's going to be the case. But it will help you identify that device. Or at least I shouldn't say you, but the system. And by default, the lsblk command will print all block devices except RAM disk in a tree-like format. So you'll have like the primary disk, and then you'll have any partitions underneath that that are underneath that disk. Now let's go ahead and actually execute the command. And one other thing I wanted to tell you is if you do want me to go ahead and cover, I know I just kind of briefly touched on the sysfs /sys directory and udev. If you want me to cover anything else on that, please let me know down in the comments. I'm also going to leave a video from a great Linux YouTuber named DJ Ware down below to kind of cover those things in more detail if you don't want me to make that video and you want to use an existing one that's already available. So let's go ahead and execute the command and go over the output, shall we? The name right here is going to be the actual name of the device. Now, devices like their actual physical, like I shouldn't say they're physical, but all the files that are associated with that device are going to be in the /dev directory. So this first column right here is the name. So if you want to know where the actual file location of that device is going to be, just put /dev in front of that, and then / and then whatever this name is, and that's going to be the actual file location on your file system. Now you'll see these devices appear at the top. These are loop devices. A loop device is a block device that maps its data back to a regular file system or to another block device as opposed to an actual physical block device. Because typically, most of these devices that you're going to see here are going to be, with the exception of loop, are going to be actual physical type device, something you have plugged into your system, whether it be NVMe, USB, SATA, or whatever the case is. So this is basically, mounting another file in another file in like another file system inside of like at another point inside on the system. So most commonly, this is going to be used as a mounting point for a virtual file system. The most common example is for Snap applications. You'll see this a lot when you mount. You'll see a lot of mount loops on Ubuntu-based distributions, and that's what I'm using here. I'm using KDE Neon, so that's why you see those loop devices here. So if they're there, hey, great. These are just the Snap applications, kind of putting, basically mounting all of the files that they're going to need at that specific location, and then it's going to have just access to those files from that location. Now the next column is going to be the mag, MAG : min, MIN. Now these are the first number, the major number, is going to be, it's going to associate this device back to a specific driver. So this loop device is using driver 7, the SDA is using driver 8, so is SDB, so is SDC. And then you see these min numbers, and those are basically gonna identify that that device is also using that same device driver, and this is how it is identified using that same driver. So for example, we have all of the loop devices using device driver 7, and then each of those devices can be identified, as using that, using that device driver with the min number. All right, so now, one of the things that I did want to tell you, if you want me to cover more on the loop devices, please let me know down in the comments. That's something I could definitely consider covering in the future. So make sure you're subscribed for any of that future content, as well as all the other Linux content I plan on putting out. Now, the next section is going to be RM. Basically, this is going to identify a device as removable or not removable. 1 will identify the device as removable. 0 will identify the device as non-removable. This one right here, with the ones that you're seeing here, this is actually a USB device that I plugged in after the system started up. So that's why you're seeing that one there, and I plugged it in for that very specific reason. So you'll have an opportunity to go ahead and see that. Now, the next column is going to be the size, which is exactly what you think it is. It's the size of that block device. K is for kilobytes, M is for megabytes, G is for gigabytes, and T is for terabytes. And then the next column is going to be the RO column, which is going to indicate if the device is read-only. 1 will indicate read-only, 0 will indicate not read-only. So we can see all of these loop devices are read-only, but all of the other ones are not read-only. Easy enough. And then the type is the type of device that this block device is. This is a loop device, this is a disk, this is a partition. If you have any other questions about these, go ahead and make your way to the lsblk man page, and I'll tell you more about the about the about the command as a whole, and a lot of other information. The last thing is going to be the mount point, and this is where that file system is mounted on the system. So we can see here that snap bear 5. That's where this one is located at loop 1. This one is located at media B writable. That's going to tell you exactly where it's located. So that's also what this command can be useful for. It's like, well, where does this one mounted? And you can go ahead, instead of searching through the dev file, you can go ahead and just come here, and it's like, oh, there it is. So easy enough. Now, one of the things that I did want to go, a couple things that I did want to go ahead and here and share with you is, you can see this device right here, this SDC device. That's my actual USB drive. Now, there's another command that we commonly use for looking for mounted file system, which is going to be df-tac-h. And we can see all of these right here are going to be where it's going to show you where it's mounted at. Now, if you unmount a device, df-tac8 will not show that device. So, and that's a lot of a lot of sites out there. You'll when you Google how can I find my devices, it's going to say, oh, use df-tac-h, use df-tac-h. And I remember the first time I saw that, I was like, okay, cool. And then I go in there, I'm like, whoa, what the heck's going on here? I cannot see this at all. So I was like, something's got to be going on here, and that's when I did a little bit more research, and that's how I found the lsblk command. So let me show you how this can be helpful. So what I'm going to do is I'm going to remove this. I'm going to remove the USB drive, right? So that USB drive is associated with SDC. SDC is the actual physical drive, and then the other ones right here below that are going to be the actual partitions on that device. So let's go ahead and run a df-tac-h again. And all right, well, we unmounted it, so yeah, it makes sense that it's not here. But if you did not know that, you'd be like, well, where's my device? Why can't I see it? So that's where the lsblk command comes in, lsblk. And then if we go right here, now we don't have a lot of information about it, but we can see that the device is right here. Now, if we also did this, ls dev sdc, we can also see that the device is there in the file system as well. So we know it's mounted there, but once we mount it, let me go ahead and mount that again. All right, and let's run them again. And this one's going to automatically mount, so we don't have to worry about physically mounting it. Well, here we can go. We can see df tac h, and we can see, here we go. We've got this one right here, and then this one right here. All right, so it's SD. That's their SDC partitions, and then we go back to lsblk. And again, we can see all of these other ones, and see it has additional partitions. This other one here, 4.1 megabytes, 3,000 kilobytes. If you look closely at the other output, you only see SDC 1 and SDC 4, which corresponds with these two mounted ones here. Because again, DF TAC H is only going to show you mounted devices, and this one will actually show you both mounted and unmounted devices. So super helpful. Let's go ahead and go over some of the options here. Now, it does not list every single type of device. If you want to list every single type of device, you can throw a TAC A on there. This is going to include all devices, including empty devices, as well as RAM disk devices. So we've got all of those right there. Now, if you want to go ahead and have this output in a list format versus a tree format, you would just do lsblk and then you would do TAC L. I like the tree format better just because it kind of puts everything in a little bit more orderly fashion, which I appreciate. The next command that we want to go over is going to help you filter out by specific column. So let's go ahead and do lsblk, and this is going to be TAC lowercase o, and then you'll put in the name of the field that you want. Like, say if you just want the name, you could just do like that, and it's going to put just the name. But if you want to go ahead and say you wanted to do the name and, like, let's just say mount point. I think it's mount points. All right, there we go. We've got the mount points there. So you can filter out whatever you want. Just make sure that you separate each one by a comma. Now the last one's going to be lsblk tac m. What this is going to do is it's going to tell us who the owner is, the group owner is, as well as the permissions for that particular device. So kind of like running the ls tac l for the list command. Now, if you want to go ahead and do this for a specific device, let's just do lsblk, and then what we would do is we'd do dev sdc, and there we go. That's going to give us all the information about that one specific device. So we don't have to see any of the output. And that's if you already know what your device is and you're looking to see, well, what partitions does that have, or whatever the case is. All right, so yeah, that's pretty much all I had for the lsblk command. So if you have any questions or anything, please feel free to leave them down below. Let me know if you liked this video by giving it a thumbs up, and what you liked about it down below. If you didn't like it, go ahead and give it a thumbs down, and let me know what you didn't like about it. Let me know what other content that you want me to cover, and make sure you're subscribed for all of that future content. I really want to thank you very much for watching my video, and have the greatest of days.